Good afternoon, everyone. My name is Daniel, and together with my team, we will be presenting the topic of wall cementing. Let's get started. On the slide, we will be exploring the different types of cementing used in wall operations. The first type is primary cementation, which is crucial for insulating productive zones and preventing fluid movement between formation. And this step is essential for ensuring the long-term stability of the wall. The second type is forced cementing, called squeezy cementing. In this process, pressure is applied to force the formation uh, information to force the cementing into specific areas to strengthen boarding, particularly in the wells with challenging conditions or in conventional designs. Lastly, we have cementing plugs. These are cementing barriers strategically placed in the wall to block certain sections or insulate specific zones before continuing with future procedures. Uh, this slide highlights the main objectives of cementing process in the well operations. One of the keys goals in the ensures a strong bond between the formation and the casing, proving both stability and supports to the pipe. Cementing also plays a vital role in the restricted movement of fluids between the formations, which is critical for preventing close flow and the match matching, no, maintaining reservoir integrity. Additionally to the rapid setting of cementing helps avoid unweighted flow inside the wallboard, ensuring a softer and more controlled environment. It also protects the casing from damage caused by stress, wear, and corrosion during dry operations. Another important objective is to insulate zones with either low or high pressure, which prevents potential complications like blownouts preventers, uh, potential complicate like like blackouts or fluid losses. Lasty cementing prevents to collapse of weak or inconsolidated formations, further enchaining will integrity. In the slides, we will talk about the objectives of cementations and how it contributes to well integrity. Let's start with conductor casing. Its purpose is to protect loose and shallow formations while enabling the circulation of control fluids during the drilling process. Next, we have surface casing. This is essential for preventing contaminations of shallow aquifers, providing support for the blowout preventers, BOP, and deeper casings and insulating weaker formation in the wall. Moving on to intermediate casing, it helps insulate zones with low pressures or areas prone to collapse. Additionally, it prevents fluid loss in weak formations, ensuring the wall stability. Finally, finally, we have production casing, which is critically for insulation high pressure zones and formations contain water. It also allows for selective productions, prevent fluid migrations between areas, and maintains overall well control. In this slide, we will discuss specific types of casing cementations and their objectives in well constructions. First, let's talk about the liner short casing. Its primary purpose is to reduce the amount of casing needed by covering only specific zones. It minimizes material costs while maintaining well integrity and provides a base of future operations. And next, we have the tieback casing, which extends the liner back to the surface or header point in the well. This type is particularly useful when additional support is required, especially in cases of high pressure or when the integrity of the original casing needs reinforcement. Lastly, the sub-extension casing is designed to extend the wall casing and specific selections. Topically, in the shallow formations, is necessary to ensure better protection and control in the challenging well conditions. Uh, these types of cementing are tailored to optimize well design, reduce cost, and ensure the safety and success of drilling operations. If you have any question, feel free to ask at the end.
As the next point, we have what are the parameters to consider when planning cementation? 1 point, Mexican condition of the wheel, diameter, depth, temperature, deviation, formation phases, drilling key operations, drilling time and speed, casing introduction, and circulation time before cementing. Grow composition type, volume, density, properties, previous laboratory tests with the wheel mixing water. Drilling fluid type, properties, density, compatibility with cement. The next packs, what are the physical properties of cementing survey? Density, yielding and wider requirement per bag cement. The density is a magnitude referring to amount of mass contained in a given volume and can be used in absolute for relative terms. Basically, this tells us the viscosity of our growth and how long it will take to reach the bottom of the well. The yield means how much our cement will yield to cover the well, and it is much better to have too much cement than no enough, since it will be too complicated.
Mention the calculation to her perforate to car or cementation. Number of bands of the cement, total volume, the water required, the mixture of the rod and bottom iron well during the experimenting mixing the and experimenting volume. What are the recommendations that should be observed during the roll of the casing pipe? Number 1, before starting introduction and verify 15 of the cementing additives of their external location. Number 2, place the casing pipe accessories should be column pins, cementing pins. Number 3, control rate of the casing pipe of the preventing during the factory and full loads of the circulation. Number 4, check if training casing pipe, and number 5 is the pipe intermittent when frictions and instantly and not hollow when free wind and circulates instigates the introduction for program.
The next topic is what are the recommendations to follow when the terror is at the bottom and during cementation. Movement of the casing is beneficial for better mood removal. Calculate the smoothing and surface pressures to determine the maximum reciprocating speed. And condition the drilling fluid with a plastic viscosity and gel point as low as the system allows without solids on setting on the surface. When circulating to condition the sludge, it must be done with the cost calculated for the movement to try to eliminate the gauge sludge that formed during the period in which it remained static due to the increase in temperature and loss of filtration. If possible, measure the fluid return and place level marks on the mud dams to verify that there is no flow loss during operation. The next topic is what are the types of additive used in cement. Retardants, filter, reducers, accelerators, disinfectors, extenders, dispersants, loss of circulation, controllers.